the whole idea behind collaborative filtering is, for example, I like the show Friends. And if I have another friend that also likes the show Friends, it's pretty likely that I will like whatever shows that friend likes. So similar interests. And what's new here, what's being introduced with collaborative filtering that content-based algorithms didn't have, is you actually can compare different users on your platform. So that's an added dimension where you're looking at, user patterns. So SVD actually has a really interesting backstory. Back in, I think it was 2007, Netflix used to run this yearly competition called I think it's literally just called like the Netflix competition, where they actually take a bunch of anonymized data of like users and movies. And the only information that they had was what each user rated each movie. So you would have maybe like, I don't know how big their data set was, but maybe you had like 1,000 users and all of the movies that those 1,000 users watched and rated. And back then Netflix used to be on like a 1 to 5 rating, I think. I think now it's just like thumbs up, thumbs down, but you can kind of apply the same concept. So story behind that is Netflix at that time did not have this recommendation algorithm yet. It was someone who actually entered their competition, a guy named, his name is Simon Funk, in 2007, came up with this idea. I think he was a mathematician or just someone very involved with math. Came up with this idea for this kind of algorithm. And it's now one of the leading algorithms that are being used for collaborative filtering methods. So yeah, this was back in 2007. I think he won a bunch of money. I don't think he ended up working for Netflix ever, which is funny. But yeah, that's the backstory. All right, so let's get into the algorithm. It's gonna be a little bit intimidating because there are gonna be a bunch of numbers on the screen, but hopefully through this. And yeah, any questions that you all have, throw them in the chat. I do see the questions come through. If I see a bunch of like question mark faces, I will pause for a little bit. Okay, let's get into it. Before we start, how do we set up this problem? As I mentioned, in this competition, in the Netflix competition, the only information that they had were just the ratings. They did not have any information about individual movies, like not like we had for content-based recommendation engines. We did not have their genres. We didn't even have their directors, actors, none of that. The only information that we had were ratings. And so the way that in this problem we're going to set up our data is in what's called a utility matrix. So this is what a utility matrix looks like. Honestly, the orientation of this doesn't really matter. Here, as an example, you have a bunch of users. Every row is going to be a user, and every column is going to be a movie. So this is how a utility matrix usually starts, right? Imagine Netflix has like what, millions and millions of like TV shows and movies, and a bunch of users as well. And so how the utility matrix is usually set up at the start, there are a lot of blanks. So for example, here we have user one. User one has only seen movie 1, rated it a 1, and has also seen movie N and rated it a number 3. And then we have all this other information. Because every user probably hasn't seen every movie, there's going to be a lot of blanks in this utility matrix. And the whole idea behind collaborative filtering is we're trying to fill in these blanks in some way, and then recommend the next highest. So for example, for user 1 that rated movie 1 a 1 and rated movie N a 3, the next highest thing that they hadn't watched yet was movie 2, which was a 4. So therefore the recommendation engine would be like, okay, let's give user 1 movie 2. So the algorithm we're going to talk through today is how to fill in these blanks. Also, just to mention, this is not the only way that you can fill in the blanks. There are other methods, but this is the SVD, singular value decomposition method. All right. Yeah, why was that a 4? We're going to get into the math of why that's a 4. Okay. So
real quick-ish.
Yeah.
We had one question here. Because you bought this, people also bought this, like on Amazon recommendation, be categorized as collaborative or content-based, or both?
Ooh, that's a good question. Because they had the phrase other people also bought, as long as they're considering other users, you can probably say that it's collaborative filtering.
Thought so. All right, cool.
Yeah. If it just said like similar items are, then that's more content based.
Hmm,
Yeah,
makes
that's a
sense.
good way to distinct between the two.
Yep.
Cool. Any other thoughts or questions? Let me see. I don't think I saw anything very specific in the chat either. Ooh, what kind of recommender system would it be if it wasn't ratings involved? Would it be content based? Probably. Actually, something that's pretty interesting that I've like read a bunch of stuff about is people try and proxy ratings. Like for example, let's say like Netflix or other streaming services didn't have like a rating system. They would try and think of a way to gauge what you might have rated it, maybe based on like how much of a movie you watch. Maybe in a 2-hour movie, if you only watch like the first 20 minutes, you probably didn't like it. And so they would sometimes find a way to mimic ratings.
That's interesting.
Yeah, super cool. Regarding content-based recommendations, is there a way to have it not be as aggressive to Pigeonhole users? Oh, that's a good one. Yes, there is this whole field that unfortunately we will not get into today. But there's this whole, there's this general term called regularization. And that's the whole idea behind making sure that a model doesn't, basically a model doesn't pigeonhole to any specific user, any specific user base. So there are usually methods set in place to make sure that you're not being recommended like the extreme of all extreme like horror movies, for example.
I got one quick question here. I actually think it's kind of interesting.
Mhm.
Do recommenders only use one or the other? Is there any way to kind of cross-pollinate between collaborative and content?
Ooh, very, very cool. Yes. So definitely. I would say there are a couple libraries. I forget if I talk about it later, but yes, there are some libraries that allow you to do some sort of hybrid between collaborative filtering and content-based. Some of the simplest hybrid models, you would just have 2 models and then see what the rankings are of like your top 10 most recommended coming out of each model, and you find some way to like aggregate that list of recommendations. So yeah, hybrid ones definitely definitely do exist. I think I myself have also built a couple hybrid models. Cool, exciting. These are awesome questions. All right, let's talk about collaborative filtering and this kind of intense math. So here, what we have here is a very, very simple utility matrix. So for the sake of this example, we're going to imagine that we only have 4 users and we only have 4 items. And the only blank that we have is user 1 and item 3. So in this very simplified example, all 4 users and all 4 items have been rated aside from this one. So the idea, what we're going to try and do here is figure out what the estimated predicted rating is for user 1 and item 3. So for utility matrices, and this is our utility matrix, if anyone is familiar with linear algebra, and it's okay if you're not, but if anyone is familiar with linear algebra, SVD, which is I think like material in like the last 2 weeks of a college linear algebra course, so don't worry about that at all. SVD is the process of breaking up a matrix into its components. Another word for it is matrix factorization. And factorization, if you have PTSD from like algebra math, if you remember, if you had like a quadratic equation, like x squared plus 2x plus 1, and they have you like split it up into x plus 1 times x plus 1, that was the process of factorization, is basically representing one thing as a product of 2 things. And so that's kind of what we're gonna, that's kind of similar to what we're doing here. We're trying to represent the utility matrix as a product of 2 component matrices. So what we have here, we're gonna have an item matrix and a user matrix. And essentially what we're gonna try and do, we're trying to figure out, okay, we have an item matrix and a user matrix. How can we multiply these together to create our utility matrix? More details to follow. But if you are familiar with matrices to some degree, you know that this question mark over here will be, when you multiply these matrices out, will be affected by anything under I3 here and anything under U1 here. So that's like the linear algebra part.